Hello, I am Nicholas Clark. I didn't really introduce myself. I was born in London. I moved to Vienna about 10 years ago. I work in Vienna, but I work for a Swiss headquarters firm, PayProp, that trades in South Africa, the UK, Canada, and the United States, and not in Switzerland or Austria. And all of that's fun. And this is a talk about a module that we wrote for solving a problem at work. And the module is called Test NoTtty. It's on CPAN. You could just go to CPAN and leave this talk right now. Never mind. And anyway, we are faking successful failure. And I need to do, what am I doing? Right, so my disclaimer, work runs on Linux. I know, and I've actually tested this code, it will run on pretty much any Unix-like system. I believe I've actually tested on AIX, various BSDs, this Mac, Solaris. It's just not going to run on Win32, VMS, MVS, or anything weirder. And it would actually be relevant for the Koha folks. Work chose MySQL more than 20 years ago, and so we're running with MySQL, and the examples are MySQL. There's kind of a bunch of us at work who'd love to migrate to Postgres because we like Postgres better and reasons, but we can't see how to get there from where we are or make a business case for it. So yeah, this is not specific to MySQL, it's just the examples relate to that. So this is basically a talk about how we are trying to deal with passwords and prompting for them. So if you want to connect to a database, you are going to need a username and password, more information than that, but you certainly need a password. If, like, you put your password on disk, well, you just made it easy for any attacker to steal your data and take it out, exfiltrate your data. It's trivially easy. So you think, say I put the password on the command line. Well, that's still a problem because your password will be stored in your shell history if you aren't careful about this, which is another file on disk, copy, copy, copy. Or it's still live with PS and various commands like that. You can probably look at other the command lines of other processes running on the machine. So if you've managed to break into that machine, you can start finding out database passwords, even though they notionally aren't on disk. Now, if you run, for example, the MySQL client or any other, like at the bottom there, you can put a -p. So that's saying, use MySQL, the username is root, a password, but prompt for it. And database name is statement processor. And look at the command line I wrote, where I redirect standard input from dev null, standard output to dev null, and standard error as well to dev null. And yet it still managed to say enter password and put it on the screen. How does it do that? Well, what it's doing in all these terms is getting to open your controlling terminal. Then Unix, of all of it, there's a concept of a controlling terminal. If you are an interactive session, this is. And you can get there by opening the file /dev/tty. So the thing I just showed you, you can pretty much fake in Perl by opening that file and then using something like term rekey, readline, read mode to set the no echo to stop echoing the password to the screen. Then you say, please read me a line from that file handle. And then you're being good. You turn echoing back on in case people type things again. And that pretty much solves the problem of how do I implement the thing I showed on the previous slide. Right, there wouldn't be much talk if that was all we were going on about. So the problem we're trying to solve is we have batch jobs written in Perl. Now I'd like to, how these run, okay? So these run on production. On production, the config is on disk, but that machine is heavily locked down. And even if you know the password, access to the machine is so restricted that you can't, that doesn't get you anything. You have to be on that machine, by which point probably it's game over anyway. So the config is on disk. We don't have to solve that problem. For development systems and the continuous integration systems, there's no sensitive data. There's test data there. It's all in Git anyway. So yeah, the config is on disk. It's not a problem we need to solve. But what I wanted to do was take those batch scripts and similar on my dev box and connect through our tunnel to our production read-only mirror, where I can test these things against live data without having to mirror it all to our local encrypted system, which is painful and takes time. I can immediately test something without spending several hours mirroring it and wondering how much disk space I've got and all that fun and disposing of it later. So effectively but the thing is, for that tunneling system, the password is extremely restricted. It's, one of these encrypted things I don't look at unless I have to, and copy it and goodbye. So I wanted to add that third case. I wanted to be able to have a way to also have the existing batch jobs that worked on production and on the test system also have a mode where I could get them to prompt me for a database password. And I wanted to do that without touching the code. I wanted that in configuration. Okay. So what am I trying to achieve? I want the default behavior we have unchanged. If I make a config file that looks like existing config, it still works. I optionally want it to prompt for a password. Obviously, or still, I really want it to work with redirection. So yeah, that's OpenTTY. Check most of these. And I want it to fail quickly and accurately. I don't want the failure mode if I accidentally put into production a config that says you should prompt. I don't want it to hang forever trying to read from a file handle that's closed and just something, or a file handle that hangs. I do want it to report, if I do this in production, hey, I am misconfigured. And I don't want it to report fail to open dev TTY, which is what happens if you have no terminal. I don't want it to report that. I want it to report, you misconfigured me, please fix it. So, example of configuration. I think I'm going too fast. It's really a 20-minute talk, by the way. So the top is a JSON blob of how we describe our existing configuration, and that's for the dev system, so those lovely secure passwords. The dev system would be our host is DB, the database name is statement processor, the user and password are both processor. What I would like is for the bottom config to work, that if I say that the password is null, i.e. undefined, undef, that the system will merrily prompt me for a password and then carry on. I can see the evil eye isn't looking at me. The evil eye's gone bonkers. Okay, you can't see me, never mind. So we have all our code through a DB module. I would like to take the existing database module and pretty much have that first line, my $pass, and add the next bit as my minimal change. If the password is undefined, then I should call my prompt function, which for reasons of debugging later, or testing later, sorry, I'm going to pass in the logging object, and I want to pass it two pieces of information. The prompt, the thing I said of if we got it wrong, hey, I'm production system, password is missing from configuration, or if it's the dev system, I would like it to helpfully tell me what username and hostname it thinks I'm connecting to, because there are different passwords for the different systems, and I want to know the right one, what I'm being asked for. So that's the minimal modification I wanted to make to my production code, was to add that $pass / equals. And so on production, it will report that the password is missing, and on TTY, it will ask for the password. Okay, so next. My prompt subroutine, and this is pretty much the existing work code. With code review, we found a better way to do this recently, or a tighter way to do it. I want my prompt subroutine to be take the logging object, the string that fails if the terminal doesn't open, and the prompt message if we're in the good situation. I've got a complete sanity check for the arguments. You should obviously never hit that, but your error reporting is going to be so hard if that isn't there. I want that to fail in dev very, very early. To avoid repetition, I've pulled the name of the terminal. It's always that. Ah, yes, I forgot to say earlier. This is Unix, or all Unix systems. It's not Plan 9. The file system, the same file system is available to everybody. So if you are an interactive process, sure, devtty exists. You can open it. If you're a non-interactive process, devtty still exists. You don't have a -e test and say, oh, it's not there. It's the same thing. It's a character special file, and your excitement is whether you are able to open it or not. If you're a non-interactive process, you don't have a controlling terminal. If you attempt to open this device file name, it will return with an error code, and I think it was EIO, but I can't remember. It's in the test later, I think. You get a particular weirdo error code. And so how this works is we attempt to open the file handle, and if it doesn't open, there's error handling, which basically says, is this what I expected, or is it really something really, really weird? And then Otherwise, we display the prompt code, which grabs the password and we return. Okay, that's easy. I wrote this. Cool, I thought. But how do I test this? Dev.tty always exists. It fails on open if you are a non-interactive session. If you're testing on the continuous integration system, or if you're on production, you are a non-interactive session. This is great. Because a module exists, IOPTY, yes, a pseudo terminal, which will create pseudo terminals. So on the continuous integration system, I can write a test that uses IOPTY to create a pseudo terminal, and I can test opening the terminal and with the pseudo under the pseudo terminal, and is good. And without creating, first of all, I can test opening normally and it will fail, and then I can do it in a block where I've done this, and it will succeed, and I can test this. But say I want to test it on my laptop, where in a shell window where there is a terminal. How do I drop my terminal to test it? How do I fake that case of TTY failing to open? And that is where we get to on this talk. This is the thing that the module is trying to do. So I looked. There's nothing on CPAN. Now, I know that daemons, when you start a daemon on Unix, it drops the terminal. This is kind of old school for at least 30 years. It's in Stevens, and I did take a book of advanced Unix and looked up Stevens. And the dance is roughly what I knew. You fork a child process. You call set SID to create a new session ID. And if you're a proper daemon, you fork a second time to lose your parent. And you are now in a new process group, and you don't have a terminal. It really is that simple. Okay, I could do that in Perl. How hard can that be? Yeah, exactly. There was a bit more nuance than that. So what I'm trying to achieve is this kind of fakery. I want, much like the test exception type code, I want a routine called without TTY, which takes a code block. There is a prototype to force that to be an anonymous subroutine. And whatever situation it is in, see that code? I want it to fail to open dev.tty and always get to 6 times 9. So the return 42 is never reached because I wanted to fail to open TTY, and I wanted to return to when my comment says we should get here, I want it to get there and return 6 times 9, and my answer test will be successful by returning 54 if my maths is right. I'm not trusting my maths today. And I want something that achieves that. So I set off to implement that. As I said, you fork, you set session ID. This is total fakery. It really does need to create a child process. There is no magic here. It's just a clever, I don't know. It's a brute force attempt to make it look like there isn't a child process as best we can. So we absolutely have to fork and call set session ID. We don't actually have to fork again because we don't want to get rid of our parent. So the ... is where we run the user code. And then in the parent, we wait for the child process to end. So this thing is not asynchronous in that sense. Creates a child, lets the child run, waits for it to finish. Implementation. Well, for my testing purposes, I actually needed to test exceptions. So, okay, I shall throw those down a pipe from the child to the parent. The other thing I can do relatively easily is I get the child return code, process exit code. So that's the return value from your called thing. If the child dies with the signal, it certainly shouldn't do that. The parent catches those, and the module immediately reports that as test failure. And the module tries to send all signals to the child. That is the implementation for the reasons that follow, and that means there's a whole lot of limitations. You cannot have side effects. You are a forked child. Anything in your memory is independent of the parent. If you pass in a reference and then change the contents of the reference, your parent won't see it. Sorry, we can't do that. If you change any global state, well, that's 2 copies of global state and this one gets thrown away. Sorry, we can't do that. I'm confusing the camera by waving my arms. This becomes relevant in the next slide about test counts. As I said, exceptions. Well, what can I do? I can't return exception objects. Well, I mean, you could by creating complicated ways of serializing them with serial storable or your favorite serializer. I didn't need that and I wanted to keep it simple, so there's always string exceptions. Of course, I fell over this when I tried to write some test code which was being clever. And then remembered I've only got strings. I had to do that. As I said, the function, your little block's return value is integer and uses the process return code. And the reason we're forwarding signals is because if you didn't do this and your test is slow in the child and the parent is waiting for it and you hit Control-C because you're really annoyed, Control-C kills the parent, bye-bye parent, child is still there, keeps on trucking, and some point it might do something and spew over your terminal or do the thing you didn't want it to do. So the forwarding of signals, I said, as the implementation is really to try to get Control-C to work, and it kind of does. I don't think Control-Z, like background it, works properly. I'm not trying to fix that. I was really trying to fix the Control-C case. So I proposed to put this on CPAN, and I learned a thing. I'd written the tests with just regular test more. And I got some really useful feedback from Exodus, Chad Granum, I think it is. He's the author of test 2. And my code looked like the top. Because as I said, you forked a child, and the test count in test more is global state. So test 1, test 2, OK 1, OK 2. This runs 3 and 4, OK 3, OK 4. If you didn't do anything and you run another test here, well, this thinks that 2 was the last thing it saw. It'll print out OK 3. So output, start together, 1, 2, 3, 4, 3. This is seen as a big error by the test harness. So what you have to do is, if you don't know about the magic, you test builder new, you get a copy of the singleton that's behind test more. You ask it, what was our current test count? For my arm wave example, it would have said, you've just run 2. You would call without TTY, and I wrote my subroutine that ran 2 tests. I then returned 2. There's a don't repeat yourself violation here. I wrote 2 tests, I returned 2. I then call in the parent, I update the test count and say, oh, by the way, I ran 2 tests, which means the current test is where we were plus 2. And yeah, there's a whole lot of boilerplate. And he said, look, use test 2. It's that. Use test 2 IPC, magic. Well, sufficiently advanced technology. And so that was fine. I thought, but now I have a new dependency. And I thought about and went, one of my other dependencies. So I'm going to have to pull this into the work tool chain. And oh no, it's already in core at this point. And something else depends on it. So half of CPAN modules, by the time you've installed anything like Moo or Moose or anything, you've got this in tree already. Even if you're earlier than the version of Perl that has it in the core, I think it's 5.26, because there's some point where where the implementation of regular test more is pushed over onto test 2. So you can pretty much use that already if you're using anything vaguely modern or anything more than about 2 CPAN modules. And as you can see, it makes the code so much simpler. Now, what you're expecting, and I know what my timing is, this is actually a 20-minute talk, is, well, here's the live demo, but I mean, there isn't. You can go look at the code on CPAN. I could basically show you in a terminal I'm running the regression tests. I don't see that's very useful, and it's kind of whatever. So I mean, I got some sample questions. Do bears defecate in the woods? Yeah. Is it on CPAN? Yeah. Are we hiring? Apparently, yeah. Do any have any other questions? And I've been trained, microphones are needed, I'm sure. I scared you all. Really? So on the previous version of this talk, we didn't have the URL for we're hiring, so there was a Rickroll. I will assure you that this is not Rick Astley singing, but I'm not promising you anything else. Really, no one has a question? I guess we all wrap up then. Thank you.